Hello, this is a problem I did as a bell ringer on the day before our combined Unit 1, Unit 2 test in the fall of 2020. And what I want to do is kind of give you guys the solution. Before you actually watch the rest of this, please try the problem the best you can, and you can compare what you're doing to what I'm doing. Um, so the first thing you do when you see a problem like this is you draw a free body diagram. That's super important because there's a good chance you're going to miss forces if you don't consider them all right at the beginning. So we know this box is acted on by the force of gravity. We know this box is acted on by the normal force. Because it's being pushed, there must be a pushing force or an applied force, whatever you want to call it. I'll call it FP. FA would be fine. And then there's a frictional force back this way. So we've got all our forces considered. Now we want to make our net force equation, our sigma F equation. And it's important to remember that it's only in one dimension that we can solve questions like this. So either your X or Y axis for this one-dimensional force unit is going to have its forces cancel entirely and be in equilibrium. The X axis in this case is the one that doesn't have them cancel. And sigma F is just FP minus FFR. And I guess I'm considering this the positive direction and that the negative direction. What about Fn and Fg? They're not part of the X dimension. So left can fight with right, up can fight with down, but they don't mix. If we really cared about the Y dimension, which you may eventually in another problem, then we could do Fn minus Fg. But you don't have to do that. It's only one of the two axes that's going to matter, either X or Y. And in this problem, it's X. Okay. So I would probably make my table at this point. I see 2.5 kilograms. I see 5 meters. I see 50 newtons. And I see 8 seconds. I'm going to use the units to give me a clue as to what these are. Kilograms is mass. Meters is X or XO. Newtons is one of the F's probably. Seconds is time. Since it gets to 5 meters after the motion, that's my X final. And my XO is probably 0. It says frictional force of 50, so that's FFR. All right, so now I would just try to plug into the equation I've got and see if it's solvable. FP minus 50 is 2.5 A. So not solvable. We have two unknowns. All right, so that means I should do a motion equation. I'm noticing this is a place where students are stressing. What if I pick the wrong motion equation? Not a big deal. In fact, I'm going to deliberately pick the wrong motion equation. I'm going to pick so this is what happens if you pick the wrong motion equation. There's V, I don't know it, so I'll leave it as V. VO, I don't know it. I don't know A. And I've got 8. Okay, not solvable. That wasn't the right equation. Move on with my life and pick a different one. And now I'll pick the correct one. But if I had picked the wrong one the second time, the same thing would happen. It just wouldn't be solvable. And just eventually, as long as you keep going, you're going to get the right one. So X is 5. XO is 0. That's all 0. So we end up with 5 is 1/2 times A times 64. 5 is 32A. All right, so A is 0.156 meters per second squared. So now we can go plug that in up here. So times 2.5. FP is, FP minus 50. 0.391. So we'll add 50 to both sides. FP is 50.391 newtons. All right, so that's it. At this point, we've practiced a bunch of these. If there's any step you're hanging up on, try to zero in on that step and seek help either from me or from any other resource you've got. But at this point, try not to be like, I can't do these problems. Try to be like, I have problems writing this equation. I have problems picking the right equation to use. Try to be hyper specific, and that's going to help you prepare yourself for this. One last thing, we've done a lot trying to solve problems like this. Don't forget to look at things like graphs. Don't forget to look at the net force problems with boxes. Just make sure you're reviewing the conceptual stuff as well.